Hello everyone, I hope you guys are doing good. So welcome back to another video of our Blind 75 series, and the problem we'll be discussing today is problem 198, house robber. So in this problem, we have been given that we are a professional robber planning to rob houses along a street, and each house has a certain amount of money stashed. The only constraint stopping us from robbing each one of them is that adjacent houses have security cameras, and it will automatically contact the police if two adjacent houses were broken into the same night. So we have been given an array, nums, which just tells us about the, let's say, uh, number of millions we have in cash stacked in each house. Let's say, for example, we have been given a nums that looks like this. And the only constraint over here is that we cannot rob adjacent houses. We cannot rob the first and the second house together, or second and third and fourth, and so on. So today, we'll be discussing a dynamic programming approach, or I should say two dynamic programming approaches to solve this problem. So as you can see, I've already written the first approach. So I'll be explaining this first, and then we'll be modifying it to better our problem or decrease the overall complexity of our problem. So for this solution, as we can see, first things first, we would just look into the base cases, as we have been given that the length of our array nums could be anywhere from 1 to 100. So if we have been given the length equals to 1, then we only have to return the only existing house that's there. If the length is equal to 2, let's say we have 1 and 2, then we have to return whichever has the maximum money. Let's say for this case, house number 2, or the house at the first index. Now let's talk about a dynamic programming approach. So for our dynamic programming approach, we'll have an array, dp, and we'll initialize it all zeros, same as the length of our array. Here's 1, 2, 3, 4, 5, 6. So now the main concept behind solving this problem using dynamic programming is to find subproblems. For every dynamic programming solution, you only have to find subproblems and then use your same logic in your dynamic programming approach. So here, as we can see, the given condition is that we cannot rob two adjacent houses. So for the first two houses, it's very simple, that we would go and choose the house whichever has the maximum cash tagged in it. So the main trick comes from the third house, or the house at index I equals to 2. So now we have two options. Either we rob this house and then jump to this house and rob this house, or either we only rob this house. So as we can see, robbing these two houses will give us more profit, as we'll have 5 rather than just robbing 1. Therefore, we'll go for this. In our dynamic programming or DP array, we would store the current maximum of each index, like the amount of cash that we could have collect, the maximum cash that we could have collect if we rob till this house, or till this house, or till this house, and so on. And the last, we would be returning the last element of our DP array. So as we can see in the code, these are the base cases. And now we'll start a traversal from I equals to 2 from this case till the last element, and we'll just keep on updating. And what will update is either we'll rob just the last house, or in the DP array we'll be storing the maximum that we have robbed till that element. So either we'll just, let's see, I'll take an example to explain it. If we had a case like 1, 4, 2, now either we'll rob both these, or I'll rob this. So let's say the maximum till here was 4, and now I have to figure out what would be the maximum till here, till the complete length. So it's simple that either it will be 2 plus 1, or it will be just be 4. So similarly, we'll keep on updating our DP array that for every element, for every ith element in our DP array, we would store either the maximum, of either the I minus 1th position of our DP array, or we'll go to the I minus 2th position and we'll add the current value in our nums array. So by doing this, we can easily be focusing and calculating the maximum at each index. And while traversing our array, we just have to return the final element and we'll be done with our approach. So as we can see for this, we are storing an array. So the space complexity goes straight away to big O of n. And the time complexity is also big O of n, as we are only traversing our array once. So let's check our solution. As we can see, this is an efficient solution. And now I'll be trying another way to solve this problem. There will not be much of a change, but we'll be trying and just simplifying the same logic that we put in the previous solution in the new solution. Here we'll initialize two variables, rob1 and rob2, and these mean that either we are robbing 1 or we are robbing 2. So similarly, for n in nums, we'll have a temporary variable that will store the maximum of either n plus rob1, that we are robbing the current house, and we robbed the house not adjacent to it, but 2 places before it, or we are just robbing the house adjacent to it and not robbing the current house. And after this, we'll just keep on updating our variables. We'll say now rob1 is rob2, and we'll save our temporary variable rob2. And after the traversal, we'll straight away return rob2. By doing this, now we are not storing a complete array. We are just storing a single position, a single variable, or as we can see in our cases, 3 variables. We'll try and see how the solution looks, and as we can see, it beats 99.9% users on LeetCode. So I hope you understood the problem. Thank you.